deal if you did already.
Can that be a no code?
Can that be a no card?
No. Alright, we are moving on. This is 4.10. This is the last section in chapter 4. We are proving that triangles are congruent. Okay, we have 5 ways of proving that triangles are congruent. We have already learned side, 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 HL, and side, angle, side. Those are the 3 methods that are in 4.8 and 4.9. Now we're talking about 4.10. And we have 2 methods. The first is angle, angle, side, and the other one is angle, side, angle. What is true about both of these methods?
Both have 2 angles.
Very good. They both have 2 angles. So if you see 2 angles in your triangle, immediately start thinking about either one of these. But what is true about all 5 of these? What's true at least about all 5 methods? They have to have at least what?
2 sides.
One side. A minimum of 1 side. Look, 1 side, 1 side, 2 sides, 2 sides, 3 sides. So you have to have a minimum of 1 side. But if you see 2 angles, then it's either going to be, or it could be, angle, angle, side, or angle, side, angle. It might not be anything. It might be not enough information. Okay? All right, let's look at angle, angle, side first. We got angle, angle, side, and we have angle, angle, side on that one. Now you might be asking yourself, and you might be saying to yourself, they don't look congruent, that's my fault. But you might be asking yourself, well, you only see 1 angle. Well, what kind of problem is this? What do we call this type of problem? A bow tie problem. And instantly, Kohler, when we do a bow tie problem, what are we thinking? One word, starts with a V. Kohler.
Vertex or vertices?
Vertical. When we see a bow tie problem, we are instantly thinking, see it makes a V? We're thinking vertical. Why are we thinking vertical? What do vertical angles give us?
They have the same.
They're congruent, right? This angle, they're not going to give it to us, and this angle are congruent. Okay? Those 2 angles are congruent on any bow tie problem. Anytime it looks like a bow tie, you should be thinking vertical, and you should write that in. Okay? Instantly. Alright, so we've got angle, angle, side, and we have angle, angle, side. So even though they don't look congruent, if they were drawn a little better, you would get the idea, and you have angle, angle, side. Okay? Questions? Now, is it going to be easy to confuse this one with this one?
Yeah.
Well, what's the difference between these 2? The side is in the middle on this one. Okay? The side is in the middle on this one. All right, let's do an example. Okay? Copy this down in your notes. Here you have 2 triangles. What kind of triangles are they? No. What kind of triangles are these 2 triangles?
Adjacent.
They're right triangles. They're adjacent. They happen to be next to one another. But the word I was looking for is they're right triangles. If you see a right triangle, what method are you thinking about using? You're thinking about HL. But in order to be HL, what does it have to be? You have to have the hypotenuse. Do you have the hypotenuse?
No.
No, there's no slash out there. You don't have the hypotenuse. So can you eliminate HL?
Yes.
Yeah, but you always need to be thinking HL anytime you have a right triangle. Think about it, but it doesn't have to be HL. Okay, so now what do we have? What do we have in these 2 triangles? What information are they giving us but not showing us?
They share the sides.
How do we say that? That middle side there, this side here is what? Is congruent to itself. That's how you say it. The middle side is congruent to itself, right? By the reflexive property, but I'm not asking you that. But it's congruent to itself. Okay, so that was something that they didn't give us, but we have to be able to figure out. Now we have an angle, a side, and an angle, and I got an angle and a side and no angle. But do I know this angle?
It's a 90, yeah.
Yeah, we have a theorem, right? And it says if a linear pair, if one of them is a right angle, then what does the other one have to be? It has to be a right angle. They have to be congruent. So now, do we have angle, side, angle? Yes, we do. Okay, we're able to prove that triangle 1 is congruent to triangle 2 by angle, side, angle. Very important. Where was the side on this one? In the middle, or included. The side is in the middle. Write it down. The side is in the middle. It's in between the two angles. Watch. Angle, side, angle. Okay? Now, somebody could say, Ian, and they could say, no, this one's angle, angle, side. And watch, this is their logic. You tell me what's wrong with this logic. Everybody's eyes up here. Angle, angle, side. Oh, this has got to be angle, angle, side. What's wrong with that logic?
They skipped an angle.
They skipped an angle, right? They skipped this one. You can't do that, right? It's actually angle, question mark, angle, side. And you can't do that. Plus you had another side and a side. There's a lot going on there. Okay? You have to go in the correct thing. So if you have two angles, to sum it up, what are your two options if you have two angles? It's probably either going to be angle, angle, side, or it's going to be angle, side, angle. What's the difference between these two? This one has the side in the middle. This one has angle, angle, and then a side. Angle, angle, and then a side. Questions? Any questions? All right, let's get our workbook out, and let's practice a few problems in our workbook before we do some problems out of our textbook.